In a previous video, we took a look at this expression, but we never got past the first two terms here. So I'd like to take a closer look at this expression and a few more like it. First, you don't usually see it written this way from the beginning. Usually you'll see it as -3 plus 7 plus 6, and instead of a plus negative right next to each other, it just looks nicer to use a single symbol. Right? Same with plus -5. Use a single symbol there for that. Our eyes can read this more easily than all of these double symbols next to each other, but it's too easy when we see 6 minus 2 minus 5. Am I doing 2 minus 5, or what's going on here? By rewriting a minus as plus negative, it's more clear that the negative is applying to the 2. The 2 is going backwards, the 5 is going backwards, and the 3 is going backwards, while the 7 is going forwards. The 6 is going forward, and the 8 is going forward. All right? This forward-backward movement is what we really need to pay attention to, and by writing everything with a plus makes that more clear. It also is more official because when we talk about what each of these things are, we call them terms. And in algebra, term doesn't just mean a precise word that we're defining, right? That's the general definition of term. But in algebra, a term is an input value for addition, as opposed to the sum, which is the output value for addition. All right, a couple more definitions there. So when I look at -3 plus 7, equals 4. This is the sum, right, because I'm adding. These are the two terms in my expression. So this expression has 1 plus 2 plus 3 plus 4 plus 5 plus 6 terms. So this expression also has 6 terms. It's just that separating the terms, sometimes we have a minus instead of the plus negative. Right? So this makes it more clear I have 6 terms. It makes it more clear what direction things are going. But the plus negative looks a little bad, so we have another fix for that. And that is to put in a grouping symbol to separate the plus from the negative. So in your textbook and everywhere else, when you're adding a negative value, or something with a negative in it, you're always going to have parentheses around it. Now when I'm writing my scratch work, that's a lot of extra pen strokes to have to go through, and visually, if I already know what's going on, I don't really find that helpful. So I often get lazy and drop these parentheses while I'm going through the problem. But every time a problem starts out with adding a negative, those parentheses will be there. They're not grouping an operation. There's no change in the order of operations here. It's just a way to separate these two symbols. All right, now we can get to actually working on this problem. So -3 plus 7, one way we can do this is just straight left to right. -3 plus 7. I'm going 3 to the left, but 7 to the right. That's bigger, so I'm getting to the right of 4. And then 4 plus 6, that's 10. That's easy. 10 plus -2. Okay, 10 forward, 2 backwards. It's going to give me 8. That's the same as 10 minus 2. Then plus -5. So it's 8 forwards, 5 backwards, 8 minus 5 basically. That's 3. Then plus another 8 here. And 3 plus 8 is 11. So the sum here, this whole expression, has the value of 11. If I were asked to evaluate, the value of this expression is 11. If I was asked to simplify, by performing all of these additions, I get 11. Now you notice each time I went to the next term, I brought it down, right? So I wrote 8 a whole bunch of times here, because as we're simplifying expressions, it's important that each line is equivalent to the line above it. I could put an equal sign here. This whole thing is equal to this. This line. Everything is equal to the line above it. I'm not saying 4 plus 6 equals 10 minus 2. 10 minus 2 doesn't equal 4 plus 6. 4 plus 6 is 10, and that minus 2 is part of both expressions. Right? It's a habit we want to get in, even as we're still doing some arithmetic without variables. But it's really going to be useful for you to keep things neat and organized, especially as we bring variables in. Now, left to right isn't always the best strategy. So let me just start with some new example. Let's say 346, get some bigger numbers in here, plus 87 minus 87. Going left to right, 346 plus 87. Those are both positive. So I'm over here. I've got a carry here, so 6 plus 7 is 13. 12 plus 1 is 13. 3 plus 1 is 4. So there's 433 minus 87. Okay, so 433, that's positive. The 87 is going backwards. So I'm taking the difference. Okay, I've got to borrow here. 13 minus 7 is 6. Right, I'm kind of exaggerating how hard this is, but carrying and borrowing are really annoying. I can't keep track of that in my head very well. Right? This is not something I can look at and immediately know the answer to. I have to actually work it out by hand. This I could maybe do in my head, but I have to stare at the ceiling for a little while. It's not so interesting visually for you to watch. And it's still not super easy. But the beautiful thing about addition is that it's associative. I can add these two terms first if I choose, so long as I remember which sign goes with which term. By rewriting this as addition here with the negative for the second 87, I can add these two first, which makes everything super easy. 87 forward, 87 backwards. I'm right back where I started. If I start at 346, I wind back at 346. If I started at 0, I end back at 0. Now hopefully you guys recognize that as soon as I wrote the problem down, but you definitely don't want to go through problems like this having to, okay, 12 minus 8, 4, 300 minus no 100. All right? What a waste of time. This relationship is something we do want to focus on very briefly. A couple more vocabulary words here. We use this word opposites all the time in everyday language, right? But in mathematics, it has a very specific definition. Opposites are additive inverses. That's what the word opposite means. It's very precise. Now, we need to know what we're talking about with additive inverses. An additive inverse, or additive inverses, are two numbers whose sum is the additive identity. Now, of course, you now want to know what the heck is the additive identity. It is the number that has no effect when added to another quantity. In other words, 0. Right? We've seen before three plus 0 is 3. Anything plus 0, we get back what we had, right? That's called the identity. Now, we use these fancy words because they are more ubiquitous than just 0, right? Each operation has its own identity. Identity is something we think about as you go beyond addition, subtraction, multiplication, and division. As we get into more complicated operations and algebras, we need to know about identities. Identities are the things that have no effect. So the number that has no effect when added to another quantity, that's going to be our additive identity. Well, if I have 3 plus 17 plus negative 17, that's the same as doing 3 plus 0, because the sum of these two numbers is 0, right? That's pretty much what we just looked at. So additive inverses, otherwise known as opposites, are the numbers whose sum is 0. Is 17 an opposite? That doesn't make any sense. 17 is the opposite of negative 17, and vice versa. Right? This is the opposite of regular 17. This is the opposite of x. The opposite of negative 3 is 3. Well, I guess if I'm following the path here. The opposite of negative 3, so here's negative 3, its opposite is going to be 3. So if we look at a few more examples, we did 346 plus 87 minus 87. There we go. Now we can follow this logic in our head, but I have to write it down so that you can see what's going on, because you can't see what's in my head. But if I go to another version of this, say 346 minus 87 plus 87, a lot of people are going to get stumped here when they can figure this one out. Right? Now if we do this one the long way, we'll probably get it right, assuming we don't make any mistakes, right? 346 minus 87, we have to borrow here. We can work that out and then add 87. The mistake a lot of people make is they add 87 plus 87. If I want you to add the two 87s, I need to put parentheses around it, right? These grouping symbols say, do this operation first. But without those grouping symbols, this operation is saying I'm adding 87 to what's in front of it. What's in front of it? 346 minus 87. I've got 346. I'm subtracting 87, so I'm moving 87 to the left. 346 is positive, that's going to the right. And this 87, also positive, also going to the right. In this version, both of these 87s are working together and then going to the left. This arrow would be flipped the other way. That's a different problem. Here, because these are going the same length in opposite directions, they add up to 0. They're opposites of each other. So I get 346 again. We can shift this around a little bit here. Instead of starting with 346, we could see a problem like this, where it's not so obvious that I have opposites next to each other. It's really important before you dive into a problem moving left to right that you look at what numbers are there, how they relate to each other. If I see a positive 87 being added to a negative 87, I know their sum is 0, and I'm all done. All right, let's leave these 87s alone and do one more problem. I actually started this one with 87. With a whole bunch of terms here. Go ahead, try this one on your own. I hope you saw that instead of having to do 87 plus 19, where we have to carry and then we're a little over 100, I could do 87 minus 7 first. Right? Now this isn't a true opposite. I don't have 87 minus 87, but taking away 7 from 87 gives me 80. That's super easy to deal with. I don't have to pay attention to the ones term anymore. Same thing with 19 and 51. I see both of those are moving forward, and that 1 and 9 go together. 19 plus 1 is 20. Now I don't have to think about the ones term anymore. So I've got 20 plus 50, that's 70. Now here's another one I'm not thinking about the ones term anymore. That 30 is going backwards. So 70 minus 30, that's 40. And 40 plus 80, 8, 9, 10, 11, 12. So I've got 120 here, just dealing with these terms. Now I can pay attention to the 4, which is moving forward, and the 2, which is moving forward. 4 plus 2 is 6. And done. We need to logically approach our problem. We don't want to leave any terms out and forget about them or something, so we're going to have to be paying attention as we do this. But we don't have to march left to right. We can use the commutative property of addition to really streamline our process. So I've got just a few quick tips here as we talk about streamlining this process. The first thing to look for is to always pay attention to each term's direction. I'm not really using the number line here. I didn't measure out 87 forward and then count 7 backwards, 86, 85, 84. I'm not using the number line in that way, but I'm thinking about forward on the number line versus backward on the number line. I strongly encourage you, draw these arrows in for each term. That'll really help avoid doing mistakes like subtracting 11 because you did 7 plus 4 instead of back 7 and forward 4. That'll help you recognize 19 plus 1, these are both positive. I can put that together to make 10. That's going to be one of my later tips. Whereas if this had been minus 51, that would have been worthless. So we got to pay attention to each term's direction. That's key. And that's always true, whether we go left to right or hop out of order. Our second tip is to seek out additive inverses. Even partial inverses like 87 minus 7, I'm still doing 7 minus 7 to get 0, just plus another 80, right? So getting those additive inverses just lightens our load, fewer things to keep track of. The third tip we used in this problem was to sum to 10 if possible. Once I did 87 minus 7 to get 80, I could do 80 plus 19. 80 plus 10 is 90. 90 plus 9 is 99. 100, 101, 102, 103. But to do 99 plus 4, I'm literally counting up 4. That's not very efficient. Right? And then I've got 103, then 103 plus 51. Maybe I have to write that down. 103, 51. Right? I want to avoid this kind of work as much as possible because it's tedious, it takes time, it draws my attention over to this part of the screen instead of looking at the big picture. And it's really easy to make little mistakes here, especially if we're subtracting, we might add by mistake, or adding, we might subtract by mistake if we're doing a bunch of it. It's easier for our brains to just, okay, 19 and 1, that's 20, plus 50, that's 70. All right, I already had the 80 written down. I'm not trying to keep track of everything in my head, but I'm just streamlining things. All right, so these two are just kind of my tips for how to make long problems like this easier. This is the key to all addition and subtraction of integers. All right, I hope this example and the other ones were helpful to you, and good luck on working on your own problems.